All right, let's talk about one of the most powerful things you can do with data, joining tables in SQL. Seriously, this is the secret sauce that turns a bunch of separate, messy spreadsheets into a single, cohesive story. But, to really get why it's so important, we first have to look at the absolute chaos it helps us avoid.
And that brings us to this question, right? It seems kind of backward. Why would you take a perfectly good set of information and just break it into pieces? Well, as it turns out, splitting up your data is one of the smartest moves you can make. And to really understand why, we've got to see the disaster that happens when you don't.
So, let's kick things off with a bit of a cautionary tale. Think about trying to run a business, but your desk is just a giant, unsorted pile of papers. That's pretty much the digital version of what we're about to see. What happens when you just cram everything you have into one single giant table?
Okay, just look at this thing. We've got all our student info and all our club info just mashed together. See the student Clem? He's in 3 different clubs. That means his personal info, his class, his teacher, gets repeated 3 times. Same thing for the club info. The ICT club's advisor, Mr. Swen, is listed over and over and over. Now this isn't just messy, it's a ticking time bomb.
This whole problem actually has a name. It's called data redundancy. And it just means you're storing the exact same piece of information again and again. And yeah, it wastes a little space, but trust me, that is the least of your problems. The real danger here is that it makes your data incredibly fragile and super easy to break.
For example, let's say Clem moves to a new class. To update that, you can't just change it in one place. Nope. You have to go on a hunt and find every single row where his name shows up. And if you miss just one, bam, your data is now inconsistent, which means it's officially wrong. This little nightmare is called an update anomaly, and it's why there has to be a better way.
And that better way starts with doing the one thing that seems so crazy at the beginning, splitting up the data. By breaking our information into logical, self-contained little tables, we can get rid of all that repetition and build a system that's way more reliable. And here is that solution in action. On the left, you see our old, messy table. And on the right, 2 beautiful, clean, focused tables. One is just for students, and the other is just for clubs. Notice how Clem's info now only appears once? The club details, just once. Every single piece of data now has one and only one home. But that brings up a new problem, right? How do we link them back together?
Well, the first part of our puzzle is something called a primary key. The easiest way to think about this is like a unique serial number for every single row in a table. In our student table, the student ID, or SID, is the perfect primary key. No 2 students can have the same one, so it's a guaranteed way to identify each person.
And now for the real magic, the foreign key. This is a column in one table that literally points to the primary key in another table. So to link a student to their club, we just add a club ID column to our student table. That club ID is our foreign key. It's the superglue that holds the relationship between our 2 tables together.
Okay, deep breath. Our data is clean, it's organized, and it's all linked up. It is time for the data reunion. Let's see how we can bring these 2 separate tables back together to answer some real questions. And we'll start with the most common type of join there is, the inner join.
So here's our first table, students. We've got their name, and most importantly, we've got that foreign key, club ID. That little number tells us which club each student has joined.
And here's the second piece of the puzzle, our clubs table. This lists each club's ID, that's its primary key, along with its name and room number. The ID in this table is exactly what the club ID in the student table is pointing to. We now have all the pieces we need.
So, what does an inner join do? Think of it like a matchmaker. It looks at both of our tables and says, I am only going to combine rows where the club ID in the student table perfectly matches an ID in the club table. It only brings back the confirmed pairs. No match, no entry.
Now don't let the code freak you out. This is way simpler than it looks. All it's really saying to the database is, hey, show me the student's name and the club's name. Do that by joining the student and club tables wherever a student's club ID is the exact same as a club's ID. That's it.
And boom, there's our result. The database did exactly what we asked. It went through, matched up each student with their correct club name, and gave us a beautiful combined answer. We've taken data from 2 separate places and put it together. But hang on a second. If you look at our original student list, somebody's missing.
Yeah, that inner join was great, but it was also a little exclusive. It only invited people to the party who had a definite match. But what if we want to see everyone on the list, even the people who haven't joined a club yet? For that, we need a different tool, the left join.
So what happened? Well, if we look back at our student list, Bem's Klub ID was empty, or what we call null. Because he didn't have a matching ID in the Klub table, the inner join just left him out completely. Poof! He vanished from our results, which is definitely not always what we want.
A left join totally fixes this. It puts all its focus on the first table you list, the left one. It basically says, give me every single record from the student table, no exceptions. Then, if you can find a matching club for any of them, cool, bring that info along. If you can't, just leave it blank.
And look how simple the change is. The command is almost identical. We literally just swapped the word inner for left. That one little word completely changes our priority and tells the database to make sure every single student is accounted for.
And here we go. Ben is back. The left join kept its promise. It included every single student. For Ben, since he doesn't have a matching club, the database just puts null in the club name column. And now, finally, we have a complete picture of all our students and whether or not they're in a club. So let's just step back for a second and think about what we just did. By first splitting our data up and then learning how to intelligently bring it back together, we've unlocked a way more powerful and way more reliable way of working with information.
And this all matters for a couple of huge reasons. First, by getting rid of all that repetition, we protect our data. It's now consistent, it's trustworthy, and it's safe from those really dangerous update mistakes. And second, and maybe most importantly, it gives us incredible flexibility. We can now connect our data in all sorts of different ways to find insights we never would have seen before.
And that right there is the big idea. We've only just scratched the surface here with 2 tables. Imagine joining student data not just to clubs, but to tables for their grades, their attendance, the library books they've checked out, the sports teams they're on. The power to connect all of that different information is what turns raw data into real knowledge. And it all starts with mastering the art of the join.